All right, so quantum computing. We're diving into that today.
Okay.
We've got this really interesting article from Insider Release. It's called Quantum Computing Explained, the Future of Science and Military Applications.
Right.
And it was published about 3 months ago.
Okay.
And it basically paints this future where the computers that we have today are going to be considered like slow and primitive relics.
Interesting.
So, are you ready to kind of explore this world of quantum computing, how it could revolutionize everything from like science to the military?
Yeah, absolutely. It's one of those fields that's just like advancing so rapidly.
Right.
It has the potential to like really transform so many different parts of our lives,
Yeah, for sure. So the article starts out
Okay.
talking about how quantum mechanics, with all of its crazy principles, really paved the way for the development of these quantum computers.
Yeah.
And this goes all the way back to the 1980s. So I'm kind of curious, what sparked that leap from this theoretical world of quantum mechanics to actually building a new type of computer?
Well, I think it was a combination of things, right?
Yeah.
You had these brilliant minds,
Mm.
and they were able to recognize that, hey,
Yeah,
if we could harness these quantum phenomena
right.
for computation, there's huge potential there.
Okay.
Like physicists like Richard Feynman, they realized
Yeah.
that to simulate quantum systems on our classical computers, it was incredibly inefficient,
Right.
borderline impossible for certain complex systems.
Wow.
So they proposed this idea, what if we used quantum systems themselves to actually do the computations?
Oh, wow.
And that's kind of how the seeds for quantum computing were planted.
So instead of trying to force our computers to understand the quantum world, we're building computers that speak the language of quantum mechanics.
Exactly.
That's like wild.
It is, and at the heart of this new type of computing is the qubit. And unlike a classical bit, which everyone knows can either be a 0 or a 1,
Right.
a qubit can actually exist in a superposition of states,
Okay.
which means it can be both 0 and 1 simultaneously.
So that's where like the coin analogy comes in, right?
Yeah, exactly.
Like if you flip a coin up in the air, it's not heads or tails until it actually lands.
Yeah, that's a good way to visualize it.
Right.
But I think it's important to remember that superposition is a lot more complex than that.
Okay.
It's not just like two possibilities coexisting, right? It's about the qubit existing in this state that encompasses a blend of both possibilities.
Okay.
And then there's a certain probability that it'll collapse to either 0 or 1 when it's measured.
So it's not even just holding those two possibilities. It's like existing in a state that's kind of a blend of both.
Yeah, it's more nuanced than just heads and tails, for sure.
That's a lot to wrap my head around.
I know, it's one of those things that
Yeah.
makes quantum computers so powerful.
Uh,
But it gets even more interesting, I think, when we start talking about entanglement.
okay, entanglement. Yeah, that's the one that really gets me.
Right.
It's the article describes it as this connection between qubits, no matter how far apart they are.
Mm-hmm.
And so you could have like two qubits miles apart.
Yeah.
And if you measure one and find out it's a 0,
Right.
the other one instantly becomes a 1.
Yeah.
How is that even possible?
Well, entanglement is a real phenomenon,
Okay.
and it's been verified experimentally.
Oh, wow.
And it really is one of the most bizarre and counterintuitive things
Right.
about quantum mechanics. Even Einstein called it spooky action at a distance.
So it's not just theoretical.
No,
It actually happens.
it's something that happens in the quantum world.
Wow, that's pretty mind-blowing.
I know, it's wild.
So that article suggests that it's this entanglement,
Right.
along with quantum interference, which is where these like possibilities can amplify
Yeah.
or cancel each other out.
Exactly.
That's what gives quantum computers their like incredible power.
It is, yeah.
That's
They can perform computations
right.
that classical computers just can't do.
Yeah.
So, like, imagine you're trying to search through a maze.
Okay.
A classical computer would have to go down each path one by one.
Right.
But a quantum computer, using superposition, could actually explore all of the paths simultaneously
Oh, wow.
and find the solution much faster.
So it's like having a team of explorers
Mhm.
all searching each path at the same time
Exactly.
versus just one explorer going down each path individually.
Exactly. That's a really helpful analogy.
Yeah?
And the article mentions that this kind of computational power, it could lead to like breakthroughs in all sorts of fields like medicine,
Wow.
materials science.
Absolutely.
Can you like give me an example like how this might actually play out in the real world?
Well, take drug discovery, for example.
Okay.
Right now, developing new drugs is a really long and expensive process.
It often involves like a lot of trial and error.
Right.
But with quantum computers, we could actually simulate the interactions between molecules
Okay.
with incredible precision.
Wow.
So we could design drugs that target specific proteins or disease pathways
Okay.
much more effectively.
So instead of testing thousands of compounds in the lab, we could use these quantum simulations to identify the most promising candidates
Exactly.
that would like revolutionize the pharmaceutical industry.
It would. And it's not just limited to medicine.
Okay.
In materials science, we could design new materials
Right.
with specific properties like superconductivity or increased strength, leading to innovations in like everything from energy storage
Wow.
to construction.
So it sounds like quantum computers have the potential to like unlock this whole new era of like scientific discovery and technological advancement.
Yeah, it really does.
But this article also gets into this more complex side of quantum computing, which is its impact on cryptography, the science of secure communications.
Right.
And it suggests that quantum computers could both break our current encryption methods and create like unbreakable new ones.
Yeah, that's right.
It's kind of a double-edged sword there.
It is.
So a lot of our current encryption methods, they rely on this idea that it's really difficult to factor large numbers. And that would take classical computers an impractically long time to solve. But quantum computers, with their unique capabilities, they could potentially crack these codes much faster.
They could, yeah.
So it's like having this lock that's incredibly difficult to pick with, like traditional tools. But then a quantum computer comes along with this master key that can just like open it instantly.
Right.
That's a little unsettling, to say the least.
It is. And that's why researchers are working on something called post-quantum cryptography,
Okay.
which is basically developing new encryption algorithms
Okay.
that are resistant to quantum computers.
So are we going to be okay?
I think so, yeah.
Okay.
The good news is that quantum mechanics also offers a solution here.
Okay.
It's a technique called quantum key distribution, or QKD.
QKD.
Yeah, okay, how does that work?
So QKD leverages these principles of quantum mechanics,
Okay.
particularly this idea that observing a quantum system inherently changes its state.
Okay.
So that means if someone's trying to eavesdrop on a communication secured with QKD, they'll inevitably leave a trace.
Right.
And that alerts the legitimate parties that, hey, something's going on here.
So it's like having an alarm system built into the communication itself.
Exactly.
If someone tries to like peek in, the alarm goes off, and
Yeah.
everyone knows the message has been compromised.
That's a good way to put it, yeah.
Okay.
And QKD provides this way to establish a secret key
Okay.
between two parties
Mm-hmm.
with a level of security that's, like, theoretically unbreakable,
Wow.
even by a quantum computer.
That's reassuring, I guess.
Yeah. So, while quantum computing poses this threat to our current security systems, it also offers this potential solution
It does, yeah.
for creating ultra-secure communication in the future.
It's really interesting how it can be like both disruptive and innovative.
Yeah, that's fascinating.
But it's not just about codes and communication, right?
Right.
The article also highlights the potential military applications.
Okay, so let's talk about that.
Yeah.
So what about the military? What's the potential impact of quantum computing on warfare?
I mean, it's pretty significant.
Okay.
Imagine being able to analyze like real-time battlefield data with crazy speed and accuracy.
Okay.
That would allow military leaders to make faster and more informed decisions.
So instead of relying on traditional intelligence gathering,
Right.
which can be slow and like prone to errors,
Yeah, exactly.
we could have these quantum computers processing huge amounts of data and providing like real-time insights.
Yeah, things like enemy movements,
Right.
troop deployments, potential threats,
Wow.
all of that.
That could really change things up on the battlefield.
It could revolutionize tactics and strategies.
Yeah.
Imagine being able to predict enemy movements with high accuracy,
Right.
or optimize troop deployments to minimize casualties, or even develop countermeasures to new weapons
Oh.
before they're even deployed.
So it's almost like having the strategic chess player who can analyze millions of moves in an instant,
Right.
always staying like one step ahead of the opponent.
Exactly.
That's a pretty significant advantage to have.
It is.
But it also raises some like ethical questions, right?
Of course.
This potential for autonomous weapons systems
Yeah.
guided by quantum computers seems like something we need to think about really carefully.
Absolutely.
Like, are we ready for that?
Yeah, the use of quantum computing in warfare raises all sorts of complex ethical and moral considerations.
Right.
The idea of autonomous weapon systems making life or death decisions without any human intervention, that's something that needs a lot of scrutiny and debate.
Yeah, it's a good reminder that with any powerful technology, it's not just about what we can do, but
Exactly.
what we should do.
We have to be careful.
Right.
We need to make sure that ethical considerations are at the forefront
Hmm.
when it comes to developing and deploying quantum computing.
Especially in sensitive areas like warfare.
Yeah, especially in warfare.
Yeah.
Yeah,
So it's clear that quantum computing is this field with like immense potential
it is.
and these profound implications.
Yeah,
But building these machines and harnessing their power, that's not easy, right?
right. Developing and building quantum computers presents a whole new set of challenges.
So let's talk about those challenges.
Okay.
What are some of the hurdles researchers are facing?
Well, one of the biggest is creating and maintaining stable qubits.
Okay.
They are so sensitive to their environment.
Oh, wow.
Like even the slightest interference, like temperature fluctuations or vibrations,
Yeah.
can cause them to lose their quantum properties.
So it's not just about building the computer.
Right.
It's about creating an environment where these qubits can do their thing.
Exactly. It requires incredible precision and control over the environment.
Wow, I can only imagine.
It's kind of like trying to build a house of cards in a hurricane.
Oh, geez.
It's tough.
Right. And then there's the software side of things, too.
Oh, yeah.
Developing algorithms and programming languages for quantum computers. That's got to be a whole different ballgame.
It is, absolutely.
Yeah.
We need to develop entirely new programming paradigms
Okay.
that take advantage of these quantum phenomena like superposition
Right.
and entanglement.
So it's not just about adapting the code we already have.
Yeah.
It's about thinking about computation in a completely different way.
It's a totally new way of thinking about it.
So it's not even just about upgrading the hardware. It's like rewiring our entire approach to software development.
Exactly.
Wow.
And that requires a ton of collaboration
Okay.
between physicists, computer scientists, mathematicians,
Yeah.
engineers, everybody,
Wow.
all working together to create the tools
Right.
and frameworks needed to really unlock this power of quantum computing.
It's amazing how this field is bringing together expertise from so many different areas.
It is. It's really cool.
Yeah.
And I think as we keep pushing the boundaries,
Mm-hmm.
we're going to encounter new challenges and unexpected hurdles all the time.
So with all these challenges, where are we right now?
Oh,
Like in the development of quantum computers,
okay.
are we close to having fully functional, commercially available quantum computers?
Not quite yet,
Okay.
but we're making really good progress.
Okay.
So in 2019,
Mm-hmm.
Google, they claimed they achieved quantum supremacy.
Quantum supremacy.
Yes.
That sounds big.
It was a big deal.
Okay.
They had their Sycamore processor,
Okay.
and it did this specific calculation in 200 seconds.
Right.
That would have taken the world's most powerful supercomputer thousands of years to
Wow.
complete.
That sounds like a huge leap forward.
It was
So does that mean we're going to have quantum computers in our homes soon?
not exactly.
Okay.
So Google's achievement, it was a big step,
Mm-hmm.
but it was a very specific task.
Okay.
It wasn't a demonstration of general-purpose quantum computing.
Right.
We're still in the early stages,
Okay.
but the pace of innovation, it's accelerating.
So it's like the early days of aviation.
Kind of, yeah.
Like the Wright brothers proved that flight was possible,
Uh-huh.
but it took decades for airplanes to become commonplace.
That's a good analogy.
Okay.
We're still in that, like, Wright brothers phase of quantum computing.
Okay, I like that.
We've proven the concept,
Mm-hmm.
but there's still a lot of work to do
Yeah.
before these machines are widely accessible and commercially viable.
I want to ask about the quantum internet that the article mentions.
Yeah.
It sounds like something straight out of science fiction?
It does, doesn't it?
Yeah.
But it's an idea that's getting more and more attention
Okay.
in the scientific community.
So what is it?
Basically, it would involve using quantum principles
Okay.
to transmit information in a way that's fundamentally more secure
Okay.
than our current internet.
So instead of sending bits of information
Mm-hmm.
through fiber optic cables,
Yeah.
we'd be sending qubits through a quantum network.
Exactly.
And because of quantum mechanics, any attempt to like intercept or eavesdrop on a quantum communication
Mm-hmm.
would basically alert the sender and receiver.
It would, yeah.
That's wild.
It's like a self-destructing message.
Right. That disintegrates if anyone tries to read it
That's a good way to think about
without authorization. Wow, that's a whole new level of security.
it. It is.
So a quantum internet, it could do more than just secure communication.
Yeah, potentially.
Okay.
It could also enable new forms of distributed computing and sensing.
So imagine a network of interconnected quantum computers working together to solve problems
Hmm.
that are like impossible for even the most powerful supercomputers today.
Yeah, it's mind-blowing to think about the possibilities.
Yeah, it's incredible.
It really is.
As this research and development in quantum computing keeps going,
Mhm.
who knows what other crazy discoveries and innovations are waiting for us?
Nobody knows.
Right.
Yeah,
It's exciting.
it is.
But I think we need to pause here for a second
Okay.
and let all this information sink in.
Sure.
It's been a lot.
It has.
This
Yeah.
whirlwind tour of the world of quantum computing.
It's a lot to take in.
Yeah, we've gone from the mind-bending principles of quantum mechanics
Hmm.
to the potential applications in science, security, and the military.
Yeah, we've covered a lot of ground.
But there's still more to explore, right?
Always more to explore.
Yeah.
Yeah. As we've seen, quantum computing has this crazy potential
Yeah.
to revolutionize so many things like medicine, materials, science,
Mhm.
even national security.
Right.
But it's not a silver bullet. You know,
Right.
we have to remember that there are still significant challenges ahead.
Yeah, you're right. It's easy to get caught up in all the excitement.
Yeah.
But we need to be realistic, too, about the hurdles,
Exactly. And one of the biggest challenges is scalability.
Okay.
Building quantum computers with a large number of stable qubits, it's really tough.
Right.
I mean, right now we're working with systems that have maybe dozens or a few hundred qubits.
Yeah.
But to solve really complex problems,
Yeah.
we're going to need computers with millions or even billions of qubits.
So it's not even just about getting those individual qubits to work.
No.
It's about getting massive numbers of them to work together.
Working together reliably.
Okay.
Yeah.
That sounds like a huge engineering challenge.
It is. Each qubit needs to be precisely controlled
Okay.
and isolated from its environment to keep those quantum properties.
Right.
And as we add more qubits, the complexity of the system just explodes.
Yeah, I bet.
It makes it so much harder to maintain that stability and coherence.
It's almost like you're trying to orchestrate a symphony
Mhm.
with millions of instruments
Right.
all playing perfectly in sync.
That's a good analogy.
Yeah.
And then you've got the problem of error correction.
Okay.
Qubits are so sensitive
Right.
to any noise or interference,
Mhm.
and that can lead to errors in the computation.
Right.
So we need to come up with robust error correction techniques.
So we're not just trying to build a bigger quantum computer.
Right.
We're also trying to make it more resilient,
Mm.
less prone to errors.
Yeah, and it's a whole other layer of complexity on top of everything else. But it's an area where there's a ton of research happening right now.
Okay.
And there are a bunch of different approaches to quantum error correction,
Right.
each one with its own pros and cons.
You mentioned earlier that we need new programming languages and algorithms.
Yeah.
For quantum computers,
Right.
what makes them so different?
Well, quantum computers operate on totally different principles
Okay.
than classical computers. We can't just take existing code and try to run it on a quantum computer.
Right.
We have to develop brand new algorithms
Okay.
that can leverage quantum mechanics.
Right.
Like, think of it like trying to teach a dog to speak French.
Okay.
It's not just learning new words.
Uh-huh.
It's about understanding a whole different way to communicate.
Right. So it's a whole different way of thinking about computation.
It is, and that's exciting.
Yeah.
But it also means we need to train a whole new generation of programmers
Right.
who know how to work with these quantum systems.
Okay.
People who understand these concepts.
Right.
And can develop algorithms that actually use the power of these computers.
This all sounds really complex and challenging.
It is. It is.
Are there any areas where we're going to see quantum computers actually being used?
Well,
Like in the near future?
I think so.
Okay.
Even with all the challenges, there are some areas where quantum computers might start making a real difference pretty soon.
Okay. Like what?
Like material science,
Oh.
quantum computers could be used to simulate the behavior of molecules and materials
Okay.
with crazy accuracy.
Mm-hmm.
And that could lead to new discoveries,
Oh, wow.
new materials with enhanced properties.
So instead of spending years in the lab
Yeah.
trying out all these different combinations of materials,
Right.
we could use quantum simulations to speed up the process.
Exactly.
Wow.
Imagine designing materials with specific properties,
Okay.
like superconductivity
Right.
or increased strength,
Mm-hmm.
just by manipulating their atomic structure.
Wow. That could revolutionize so many industries.
It could. Things like energy, transportation, manufacturing.
Okay.
It's pretty exciting.
Another area where quantum computers could be a game changer is optimization problems.
Oh, yeah.
So many problems in the real world
Mm.
are about finding the best solution out of a ton of possibilities.
Exactly. Think about logistics, financial modeling, drug discovery.
Okay.
These are all areas where quantum computers could outperform classical computers.
So instead of just trying every single possibility,
Right.
a quantum computer could just, like, instantly figure out the best solution.
Yeah, it could save so much time, money, and resources.
Right.
And this could have applications in healthcare, finance, transportation.
Okay.
Like optimizing traffic flow in a city to reduce congestion,
Right.
or coming up with personalized treatment plans
Wow.
based on someone's genes.
It's incredible to think about all the potential,
It is.
but we've talked a lot about the good stuff.
Okay.
What about the risks?
That's a good point.
What are some of the things we need to be careful about?
Well, one of the biggest concerns is cybersecurity.
Right.
As we talked about before, quantum computers could crack the encryption methods
Yeah.
that we rely on for everything online.
Right. Online banking, secure communications.
It's a big deal.
Yeah, it's kind of scary, actually.
It is, and that's why the research into quantum-resistant cryptography is so important.
Mm-hmm.
We need to develop new ways to encrypt information that can withstand attacks from quantum computers.
So it's almost like a race against time.
It is.
As these quantum computers get more powerful, we need to develop stronger defenses.
Exactly. We need to protect our data and infrastructure.
And it's not just about protecting data.
Right.
There are also concerns about how quantum computers could be used for surveillance
Oh, for sure.
and even warfare.
Absolutely.
Being able to process tons of data
Yeah.
and break encryption, it could give governments and militaries a lot of power.
It would give them unprecedented capabilities for surveillance and intelligence gathering.
And that raises some big questions about privacy
Yes, it does.
and civil liberties.
We need to be talking about this more.
Yeah.
We need to have open and honest conversations about the potential downsides of this technology.
Right.
And we need to set clear guidelines for how it can be used ethically and responsibly.
So it's not just about the technical challenges.
No.
It's also about the ethical and societal implications.
It's about all of it.
Yeah, we need to make sure that this powerful technology is used for good
Right.
and not for harm.
And that conversation needs to involve everyone, not just the scientists.
Right.
We need policymakers, ethicists, and the public involved.
It's a good reminder that technology doesn't exist in a vacuum.
No, it doesn't.
It's shaped by us, by the choices we make as a society.
And the values we hold.
And as we go into this new era of quantum computing,
Mm-hmm.
it's more important than ever to be having these conversations
Absolutely.
about responsible innovation and ethical development.
I agree. We need to be thinking about the risks, the challenges,
Right.
and working together to make sure that quantum computing benefits everyone.
That's a powerful message.
It is.
It's easy to get caught up in the possibilities, but we can't forget about the potential consequences.
It's a tough balance, but I'm optimistic.
Okay.
I think that if we plan carefully,
Mm-hmm.
have open and honest discussions,
Right.
and stick to our ethical principles,
Yeah.
we can use quantum computing to make the world a better place.
That's encouraging.
It is.
We're at a crucial point
We
in
are.
the development of this technology,
Yeah,
and the choices we make now will have a huge impact on the future.
they will.
But with all the challenges and uncertainty, what excites you most about the future of quantum computing?
You know, despite all the challenges, I'm incredibly optimistic.
Okay.
What excites me the most is the potential for scientific discovery.
Okay.
Imagine being able to simulate how molecules behave at the quantum level.
Wow.
That could give us new insights into the fundamental laws of nature.
It's like having a new way to see the universe,
Yeah.
a way to understand how things work at the most basic level
Exactly.
in ways we never thought possible before.
Think about it.
Mm-hmm.
We could unlock the secrets of photosynthesis,
Right.
develop new energy sources,
Mhm.
design drugs that target diseases with incredible precision.
Wow.
The possibilities are endless.
Yeah.
Even with all the problems we face, our ingenuity and our desire for knowledge keep pushing us forward.
And who knows what breakthroughs are still to come.
I know, right?
It really is an exciting time to be alive,
It is.
to see this technological revolution happening.
It's amazing.
But it's also a time to be thoughtful
Yes.
and consider all the angles.
We need to approach this new era with a sense of wonder
Mm,
but also with a sense of responsibility.
well said.
Thank you.
We've covered a lot of ground today,
We have.
exploring the mind-blowing concepts, the transformative potential, and the ethical challenges that are out there.
It's been a fascinating conversation.
It has.
I appreciate your thoughtful questions.
Well, thank you.
It's been great talking with you.
Before we wrap up,
Okay.
I want to leave our listeners with a final thought-provoking question. We've talked about how quantum computers can solve these super complex problems, how they
Ah.
can speed up scientific discovery and even revolutionize warfare.
Yeah, it's been a lot.
But I want to shift gears for a sec
Okay.
and think about something a little more personal.
Interesting.
So we talked a bit about the quantum internet earlier.
We did.
It still seems like something out of science fiction,
It does, yeah.
but it's something that researchers are actually working toward.
They are. It's a fascinating idea.
So how might this development of a quantum internet
Okay.
change how we live and work and
Mhm.
interact with each other?
That's a big question.
Yeah.
It is.
I want our listeners to think about that
Oh,
as
yeah.
we wrap up this deep dive.
I think it's a question that deserves some thought.
Yeah.
The implications of a quantum internet are huge.
Right.
And in a lot of ways, we don't even know what they are yet.
Yeah,
It's uncharted territory.
it is.
But that's what makes it so exciting.
On the one hand, we could see this world with incredible cybersecurity,
Right.
where our data is protected even from these advanced quantum computers.
Mm-hmm.
But then there's the other side of that,
Yeah.
the potential for misuse. New kinds of surveillance or control that we haven't even thought of yet.
That's a really important point.
Yeah.
With any powerful technology, there's always the potential for both good and bad.
Right.
And it's up to us as a society
Mm-hmm.
to make sure we're using it in a way that benefits everyone.
And it's not just about security and control either.
Right.
Think about the potential for scientific collaboration
Yeah.
on a global scale.
Researchers could share data,
Right.
work together on complex simulations,
Yeah.
all in real time,
It'd be amazing.
no matter where they are in the world.
It could revolutionize so many fields.
Well, it could.
Medicine, material science, climate modeling.
Absolutely.
But then there's also the question of access.
Oh, yeah.
Will a quantum internet be available to everyone?
Mm-hmm.
Or will it just make the digital divide worse?
That's a crucial question.
Yeah, we need to make sure that the benefits of this technology are shared,
Right.
that it doesn't just become another tool for exclusion.
I agree.
And beyond all the practical stuff,
Okay.
I wonder how a quantum internet might change how we interact with each other
That's interesting.
socially,
Yeah.
Could it lead to new forms of communication
Maybe.
that go beyond language and distance? Could it help us feel more connected?
Possibly.
Or could it create new barriers and divisions?
Yeah. As we spend more and more time in the digital world.
These are all things to think about.
There.
As we enter this new quantum era, it's a reminder that technology isn't just about the technology itself.
Right.
It's about people
It is.
and the choices we make.
And how we use these tools will shape our world.
So, to wrap things up,
Okay.
I want to encourage everyone listening
Mm-hmm.
to stay curious, stay informed, and stay engaged in these conversations that are going to shape our quantum future.
It's an exciting time to be a part of it.
It is.
Thanks for having me.
Thank you for joining us on this exploration of quantum computing. We hope you found it insightful and maybe even a little bit mind-blowing. Until next time, keep exploring, keep questioning, and keep imagining the possibilities.